Generative AI. I mean, it can write poetry, it can design products, it can even write its own code. We're talking about one of the most powerful tools humanity has ever created. But, and this is a big but, how do you build something that powerful without it going completely off the rails? Well, today we're diving into a framework designed to build AI that isn't just smart, but is also safe and responsible, right from the ground up. And this really gets to the absolute heart of the challenge, doesn't it? On one hand, you've got this incredible promise, AI that can create art, music, and text that feels just human. But on the other hand, there's this very real peril. These exact same systems can be manipulated into producing harmful, unethical, or even dangerous stuff. So the big question is, how do we get all that amazing promise while managing all of that scary peril? To answer that, we need a roadmap. So here's our plan. We'll start by digging a little deeper into that promise versus peril idea. Then we'll walk through a 4-stage safety plan, mapping out potential harms, measuring and mitigating them, and finally, managing the solution out in the real world. And we'll wrap things up by looking at what's coming next for AI safety. Okay, let's get into the core of it all, the 4-stage safety plan. You can think of this as a practical, really actionable process from Microsoft that gives developers a clear guide for building generative AI the right way. The whole idea here is to be proactive, not reactive, to get ahead of problems before they ever happen. And here they are, the 4 pillars of the plan. It all starts with MAP, where you basically imagine everything that could possibly go wrong. Then you measure to see how often those bad things are actually happening. Next, you mitigate, which is all about building layers of defense to stop the harm. And finally, you manage the whole thing out in the wild. Because let's be real, this job is never truly done. Let's kick things off with stage 1, mapping harms. I absolutely love the philosophy here. You have to think like a pessimist to build like an optimist. It's all about anticipating problems before they ever have a chance to reach a user. And this mapping stage, it has its own little mini process. First, you just brainstorm what could go wrong. Then you prioritize those risks, which ones are the most serious. After that, you test to see if these things can actually happen. And finally, you document and share everything so the whole team is on the same page from day one. So, what kind of harms are we even talking about here? Well, they tend to fall into a few major buckets. Things like the AI generating hateful or biased content, or just straight up making up facts, what people call hallucinations, or even giving instructions for dangerous and illegal activities. Now, to make all of this feel a bit less abstract, we're going to use a simple example for the rest of this explainer. A smart kitchen copilot, an AI app designed to help you with recipes. Seems pretty harmless, right? Well, let's see about that. And this brings us to a really critical challenge, prioritization. Think about our kitchen app. Getting the cooking time wrong for some chicken, well, that's a low-impact harm, even if it happens a lot. Annoying, but not catastrophic. But what about the app generating a recipe for a lethal poison? That is a massive, high-impact harm, even if the chance of it happening is 1 in a million. The team has to weigh both the likelihood and the impact to figure out where to focus their energy. So how do you find these hidden dangers? Well, one of the most effective methods is called red teaming. This is where testers basically become the bad guys. They intentionally try to break the system, to trick it, to push it, to say something harmful. Why? So the developers can find those weak spots and patch them up before a real bad actor does. So what does a red team prompt actually look like? Here's a perfect example. A normal user is not asking this. This is a targeted attack, specifically designed to stress test the system's safety filters. This is exactly the kind of question our smart kitchen copilot needs to be ready for. Okay, so once you've mapped out the potential minefield, it's time to actually find and diffuse the mines. This brings us to the next 2 stages, which really go hand in hand: measuring and mitigating. Measuring is all about getting a baseline, a scorecard. You create a whole bunch of test prompts designed to trigger the harms you've identified, run them through the system, and then grade the outputs to see just how big the problem really is. Now for the fix part, mitigation. And this is so crucial. There is no single magic bullet here. It's not one solution. Instead, you build a defense-in-depth strategy. Think of it like layers of an onion, with 4 distinct layers of protection to keep the system safe. The very first layer of defense is the model itself. Are you even using the right tool for the job? Sometimes a smaller, more specialized model is actually way safer than a giant do-everything one. You can also fine-tune the model, which is like sending it to a specialized school, by training it on your own high-quality data to teach it how to behave. The second layer is the safety system that's built right into the AI platform you're using. You can think of this as the AI's immune system. It's got things like content filters that are constantly scanning for things like hate speech, violence, or self-harm, and they just block it automatically before you ever see it. Layer 3 is all about how you prompt the AI. You can give it a system message, which is kind of like a constitution, defining its personality and its rules. You can also use this really powerful technique called retrieval augmented generation, or RAG. This basically means you give the AI a library of trusted information and tell it, hey, only answer using what's in these documents. It dramatically cuts down on the chances of it just making things up. And the final layer of defense is the user experience, the app itself. The way you design your interface can be a super powerful safety tool. For instance, instead of just a wide-open text box where a user can type anything, maybe you use drop-down menus to guide them. And it's so important to be transparent, to let users know the system has limits and that it can make mistakes. Now for our final stage, managing the solution. This is so critical because safety is not a feature you just ship once and forget about. It's an ongoing commitment, a process that continues long after you launch. And this means having solid plans in place from day one. You need a plan for a slow, phased rollout to catch problems early. You need an incident response plan for when things inevitably go wrong. You need easy ways for users to give feedback. It's a living system, and you have to be ready to act fast, whether that means blocking a bad user or rolling back a bad update. So that's the 4-stage framework, but the work, it doesn't stop here. As these AI models get more and more powerful, the tools we use to keep them safe have to get better too. The future of AI safety is really about moving from these manual processes to specialized, automated tools that help developers handle this incredible complexity. For example, we're already seeing the rise of these advanced safety toolkits. They can include things like prompt shields that automatically stop jailbreak attempts, or groundedness detection that fact-checks the AI's answers against real information. They can even scan for copyrighted material. These tools just make building a safe system so much faster and more effective. Which leaves us with this final, and I think crucial question. We know for a fact that AI is going to keep getting smarter at a rate that's almost hard to imagine. The real challenge, for all of us, is to make sure that as its raw intelligence explodes, so does its wisdom.